Hello, welcome back to my channel. In this video, we are going to be cracking the code on naming alkenes, the simplest organic compounds, but often a tricky topic for students. By the end of this video, you will be naming them like a pro. And stick around for a fun quiz at the end to test yourself. Let's go. Before we jump into the rules, why do we even need IUPAC names? Well, common names like acetone, formic acid can be confusing because different regions may use different names. To keep things universal and simple, chemists use IUPAC rules to name compounds logically and systematically. So what are alkanes? Alkanes are saturated hydrocarbons, meaning they only have single bonds between carbon atoms. They follow the general formula CnH2n plus 2. Simple, right? But how do we name them? Let's break this down step by step. Step 1, identify the longest carbon chain. The longest continuous chain of carbon atoms is your parent chain, and the number of carbons in this chain gives the base name. So for this example, the longest continuous chain is this. After identifying the longest chain, the next important thing to know is the prefixes. Okay? The prefixes tells us the number of carbon atoms in the parent chain. When you have one carbon, the name is met, 2 carbons et, 3 prop, 4 carbons pot, 5 carbons pent, 6 carbons hes, 7 carbons hept, 8 carbons oct, 9 is non, and then 10 carbons is dec. Those are what we call prefixes. Step 2, number the chain. So this longest continuous carbon chain that we've identified, we are going to number them. And to number them, you must number from the side that gives your substituent the lowest priority or the lowest number. So the substituents are those carbon atoms that you see attached to the parent chain. So those groups, those are the branches or the substituents. Okay? So if you number from the left, you're going to have 1, 2, 3, 4, 5, 6. So that means the positions of the branches or substituents is 3, 4, and 5. Now, what if we number from the right? You have 1, 2, 3, 4, 5, 6. The positions are 2, 3, and 4 against 3, 4, and 5. So the rule states that you're going to go with the lowest priority, the lowest numbers. That means that for this particular one, we're numbering from the right. So the greens have to go. Step 3, we're to identify and name the substituents. Now we've numbered our longest continuous chain. The next thing is to name these substituents. So identifying the substituent, this is your substituent, this is a substituent, and this is a substituent. The groups attached to the main chain is a substituent or branch. And the most common ones are the alkyl groups. Alkyl groups we end with YL. It follows the prefixes that I just showed you. 1 carbon alkyl group is methyl. 2 carbon is ethyl. 3 is propyl, and so on. So that means that my branches, this first one is methyl. This one here is also methyl group. And this, the carbon, 2 carbon is ethyl group. If we move on, step 4, assign the correct position numbers. All right. Give each substituent the lowest possible number and then list them in alphabetical order, not by the numbers, but alphabetically. And then if you have multiple identical substituents, use prefixes, di, tri, tetra. So di means two. This prefix is different from the one I showed you earlier. This one is for multiple identical substituents. So when you have two of the same substituents in different position or in the same position, it doesn't matter. Once it's two of them, you use di. Three of them, tri. Four of them, tetra. Now, when you move on from 4 to 5, it follows the same prefix that we learned before. So pent for 5, but the difference is for this multiple identical substituent is going to be penta instead of pent. 6 is heza. 7 is hepta. So instead of hept, it's hepta. Octa for 8, and nona for 9, and deca for 10. Okay, so that's the major difference, the A at the end. So remember, we name alphabetically. And when naming, the substituents, they come first. In alphabetical order, the ethyl group comes first. So I'm going to have the position of ethyl group is 3. So that will be 3 ethyl. Then on carbon 2, I have 1 methyl group. We have another methyl group on carbon 4. So that's 2,4. Now let's assume you had that methyl group, the second one, on this same carbon, probably here, all right? You're going to say 2, 2. So even though it's the same 2, you have to repeat it twice if that other one was on carbon 2. But since it's on 4, we're good. We're just going to say 2,4. And then instead of just saying methyl, methyl, we use these prefixes and say dimethyl. Okay? So we have named our substituents. Step 5, now we combine everything. So the last part would be the parent chain, which is that longest continuous carbon chain that is 6 in number. We said that 6 is hairs. So put your hairs here. Remember I said alkanes are hydrocarbons with single carbon-to-carbon chain. So this is an alkane. All alkanes will end with ANE. And that is just what you put here. And the name of this compound is 3-ethyl 2,4-dimethyl-hexane. So more examples. So you're given this and you're asked to name it. First thing you have to do is identify your longest continuous carbon chain. The longest I can see is from down here, go up all the way to this, all the way down, and then here. This happens to be the longest continuous chain that I can see, okay? Now, it means that every other thing around that is the substituent. So I'm going to have to number so as to give this substituent the lowest number possible. Now, let's start with the left. This is 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So I have positions 4, 6, and 7. Now, if I count from the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9. I would have positions 3, 4, and 6. Okay. Going by this, the side that gives the lowest number to the substituent is from my right to left. Therefore, I'm going to go with the green. So the next step is to identify our substituents and name them. I have this one here. This is 1 and 2. That is 2 carbon substituent. So that is going to be ethyl. This is 1 carbon, that's methyl. another methyl here, and then 1, 2, that is ethyl. Okay, so now that I have named all of the substituents, assign their numbers and name them alphabetically. So we have the ethyl group on carbon 3 and 6, 3, 6. You see, this is still on 6, okay? 6, then diethyl, then go on to your methyl. 4, 6 dimethyl. And since the longest chain is 9, 9 is none, and this is alkane, it ends with ANE. So the name of this compound is 3,6-diethyl 4,6-dimethyl nonane. What if you have this, no branches, just that? How would you name it? It's quite straightforward, okay? So you're gonna start by, this is 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons in total. In a line structure, all of those ends are your carbons. Now there is no branches here, so you're just going to go ahead and say oct, and this is ane, so that is octane. Okay, so when there's no branch, it's straightforward. You just go ahead, your prefix and then your suffix, the number of carbon and the ANE for alkane, and that's it. All right, it's your turn now. Please pause this video and try naming these alkanes. Comment your answers below and I will pin the best explanation. Ready, go. Okay, everyone, here is the answers. So for this one, we're just going to go ahead and number the longest chain, which is 1, 2, 3, 4, and that would be butane. 4 carbons, and then ANE for alkane. For this one here, the longest continuous chain is this. Okay, that's your longest. So now we know our longest, we're going to number. We're going to number from the side that gives the substituent a lower number. Okay, so if I number from here, 1, 2, 3, 4, 5, 6, I'm going to have 2, 3, and 4. If I number from here, 1, 2, 3, 4, 5, 6, I'm going to have 3, 4, 5 against 2, 3, 4. So going from the left is better this time. Okay. All right, so identifying the branch, this is 1 carbon, 1 carbon, and 1 carbon substituent, which is a methyl group. So to name, I'm going to start by saying 2, 3, 4, and then trimethyl, because all the substituents are the same. And then 6 carbon is hes, and that's an alkane, so hexane. So the answer for this is 2, 3, 4 trimethyl hexane. For this one, we are going to have 1, 2, 3, 4, counting from the side that gives the substituent a lower number. That is methyl group. So we're just going to go ahead and say 2 methyl, and this is butane. Okay, so 2 methyl butane. If we move on to this other one, we have the longest continuous chain is 1, 2, 3. On carbon 2, I have 2 methyl groups attached, and that is going to be 2, 2 dimethyl Since that is 3, that will be propane. Okay, so that will be 2, 2 dimethyl propane. Great job, everyone, and thank you for watching to the end. If this video helped, don't forget to like, subscribe, and hit the bell for more organic chemistry tips. See you in the next video, which is going to be naming alkanes. Bye for now, and have a wonderful day.